So we're going to work on the equations of lines today. Like I said, very algebraic geometry lesson, so I think you're going to like it. Going back to finding x and y intercepts that you're already used to doing from your Algebra 1 class. So this is kind of a review. So hopefully you will all remember what to do with this. So x and y intercepts, if we want to find the x and y intercepts, who remembers what that means, what you do for that? Yes. So we make one of them 0 so that we can solve for the other one. And then we make the other one 0 so we can solve for the first one. So you start by making yourself a little table. X is 0, and we'll plug in 0 here. Y is 0, we plug in 0 here. And then we find those intercepts. And the thing that's going to be useful about those is you can just plot 2 points, use a ruler, and then make a very nice straight line with that. So let's plug them in, just so that you can see that happening and you don't have to be overwhelmed with too much. We plug in 0 for x. 3 times 0 minus 4y equals 12. 0 minus 4y is negative 4y. And then divide by negative 4. And it gives you negative 3. Then plug it in the other one. And do take the time to actually do that so that you're practicing. The 0 comes here, goes in here. Anytime you're finding x and y intercepts, you do the same thing. Plug in the zeros. It's just the fastest, most efficient way of doing that. Yes? If it's obvious to you that when you plug in a 0, it's going to disappear, you don't have to write it. I'm just showing it so that if anybody looks back and goes, what happened to that, they can actually see what happened to it. So 4 times 0 is 0. 3x equals 12. X equals 4. Yes. If we plug in 0 for y, we plug in 0 for y, we're going to get 4. We get a different answer. If I plug in negative 3 here, I'm going to get x is going to be 0. Oh, you mean negative 3 into for x or for y? Because if you plug in negative 3 for y, you're going to get 0 for x. So we'll still only have one of the intercepts. So you have to plug in 0 for each one, and then that gives you both of the intercepts. Now, the only time when this is not good for graphing is when 0, 0 is the intercept, because then you need to find another point, but that's a special case. So here we can just plot those 2 points. 0, negative 3, that gives you your y-intercept. And 4, 0 gives you your x-intercept. And then once you have those 2 points on there, it's just a matter of taking the 2 points that you graphed and then drawing the line that goes between them. So we have our very nice graph graphed out in this way. So that's one way of finding to graph an equation of a line. This line does happen to have a slope. It does happen to have all the other things that are important. We have a slope, we have a y-intercept, we have an x-intercept. But what would be another way of graphing this? We could graph by intercepts, but what's another common way of graphing that you might remember and like? Slope-intercept form. So we could do the same problem and create the same graph by using slope-intercept form. So let's review that. We could go slope-intercept form, which means that we're going to do what? We're going to solve for y. So in order to solve for y, I need to do what? I need to get y by itself. So you need to subtract the 3x. Always do everything to both sides, not just one side. We can't combine the like terms. So since we can't combine the like terms and we're trying to get y by itself, what next then? Good. So put it over -4, divide by -4, because the -4s then will cancel out. Now it almost looks like y equals mx plus b form, but remember that this -4 is dividing both of them. So -3 over -4 is a fraction. 12 divided by -4 is how much? -3. So we now have it in slope-intercept form. And when you graph in slope-intercept form, even though the graph is already over here, what's the process for graphing in slope-intercept form? How do you do that? Where do you start your graph? I know it's been a while because this is asking you to remember back a year, but in order to do that, you start with your y-intercept. An interesting thing to note is that our y-intercept came out to be -3. It also came out to be -3 when we plugged in for x for 0. Because math has to be consistent. It has to give you the same answer both ways. So we start at -3. What's up with the 3/4 though? Okay, so negative over negative makes positive, but in y equals mx plus b, what does m stand for? Slope. This is the slope. It's the what over the what? Rise over run. So up 3, right 4. Rise 3, run 4. Starting it here, up 3, 1, 2, 3, over 4, 1, 2, 3, 4. 3/4, rise over run. It's another way of finding that same graph. So intercepts, but also by rise over run, slope-intercept form. So it's important to be able to do graphing in many different ways. It's important to be able to put it in y equals mx plus b form because it's a very nice, easy way for us to find the slope and just to have that jump out at you. Okay. So what about this new one we're going to take a look at? Graph it by putting it into slope-intercept form. What I'd like you to do is I'd like you to take a minute and I want you to just work on that, put it into y equals form, and then we'll take a look at what you got. Let's look and see what you got. So when you subtracted 2 from both sides and then you divided by 3 and you ended up with that, is this what everybody got? Yeah? So don't forget, we make a fraction. -2 over +3 is -2/3. -6 over 3 is -2. And then you want to graph it. So you would start when you do your graph. And you just take your time with that. Where will you start your graph? Start the graph at -2. It starts on the y-intercept at -2. So we would put our graph there. X and Y. So down 2 and across 3, yes. But what if I want to have more points? But we're out of space. Where else can I go? I can go up 2, back 3, yes. Because once you start the pattern, you can follow the pattern either direction. This does mean down 2 over 3, right 3. But the negative, remember the negative can live in the numerator or the denominator. So you could have it being up 2, left 3. And then you make sure that you draw your very nice line that connects all of them. And so you've got your graph right there like that. The y-intercept is the -2 and the slope is -2/3. So if you need to write that down. All right, so we do have some other things. Like, for example, if I want to write the equation of a line that has a given slope and it has a given point, it's not just a y-intercept, so it makes it a little bit harder. But what we need to do then is we need to remember the process. Now, those that have heard of a different process, because there's a couple of different equations you can start with to do these, you're allowed to use whatever process you want. However, we're going to go doing everything through slope-intercept form in this class. But if you have another process that you know of, even though I don't go over it, you're still allowed to use it. So we're going to start off, we have a slope, we have a point, and we're going to use slope-intercept form, y equals mx plus b, to plug in our values. So y equals mx plus b. Out of our given information, what here is m? Negative half. Negative half is our slope, the whole thing. And then when we plug it in, we'll plug in m here. Now, the other thing is that we have an x and we have a y that we can plug in order to find our b. It comes from the point that we've given. So when you have an ordered pair, what order did they go in? Which one comes first? The x. Good, the x and then the y. The x and then the y. So we've got, here's our x, and here's our y, and it goes right in to our equation. Our x is -5, our y is 6. Got them color-coded so that they can come in there nicely like that. So we've got our numbers, we plug them in, -6, -0.5, and -5. And then we need to solve it for b. So we multiply. -5 times -0.5 is how much? -5 times -0.5 is 5/2. Good. Positive 5/2. Now be careful here. Sometimes people get tripped up. Yeah. So what do you do to get b by itself? Move 5/2 to the other side. Good. Just take away, subtract the 5/2. Okay. I won't say the thing that sometimes people do by mistake. But if you didn't think of doing this and you thought of something else, then don't do that other thing. And we get 7/2 with that. So 6, for those that need to hear it and know how to do by hand, 6 is how many halves? 6 is what over 2? 12 over 2. Good. So 12 over 2 minus 5 over 2, 7 over 2. Our answer isn't finished yet. When we write the equation, we have to put 7/2 in for b, -0.5 in for m, and keep our x and y. Because our answer doesn't include the point -5, 6. -5, 6 is included as one of the answers, but the line that includes them includes all of it. So our answer has to include the -1/2 x and the 7/2. We could, if we wanted to, graph it. But once again, we've got some halves involved here, so it's a little bit harder to graph. We could. And you should have an idea of what you're doing with it, with the down 1 over 2. But writing the equation goes through this process. Now, I have taken the liberty of putting an example in that isn't in the book. They go straight to a word problem, but just being able to do this doesn't mean that you remember how to do all of the things when you've got 2 ordered pairs. So I want to go over that one as well with you. So we're going to write an equation of a line in slope-intercept form through -2, 6 and 3, -4. I specifically said slope-intercept. The directions in your book when you do the homework don't specifically say slope-intercept, because they're assuming that you haven't delved into algebra 2 at all, and you don't remember that there are other types of equations, which is kind of silly because even in algebra 1, you talk about point slope and you talk about standard. But what we want to do is we want to just look at slope-intercept in this course. So we've got the 2 points. So what do you think you would need to do first in order to find the equation of the line? Substitute what? Like, what do we have to? We are going to try y equals mx plus b, and we've got a couple of x's and y's, but what are we missing? Find the slope. Good, we're missing the slope. So do you remember the slope formula that we talked about yesterday?
Yes.
Okay. So y2 minus y1 over x2 minus x1. So do that. Take a quick minute and find that slope, and then we'll take a look at it. And so don't forget when you do the slope x1, y1, x2, y2, just like we said yesterday, plugging it into the formula, -4 minus 6 over 3 minus -2. Don't forget, minus negative turns into a positive. And so we get -2 for our overall slope. Then we need to plug it back in to y equals mx plus b in order to find a b again. So what goes into our spots in this case? X and what? No, go ahead. Yes, you choose one of the ordered pairs. You put the m in and you choose one of the ordered pairs. It doesn't matter which ordered pair you choose. I'm glad the way you said that. Because it doesn't matter which one. You can choose the ones, you can choose the twos. And when you actually find B, you're going to find the same answer regardless of which one you chose. I happen to have chosen the -2, 6, but you could have just as easily chosen the other one. 6 equals -2 for our slope times -2 for our x plus b. And we'll just take a quick minute to solve that out. 6 equals 4 plus b. Subtract, and we end up with b equals 2. But that's almost the answer. What is the actual answer then? Good. Y equals -2x plus 2. Excellent. So you have to plug it in. You leave it alone. You keep the x and y. The 3, -4. If we had used 3, -4, we still would have gotten the same answer. You still would have gotten a 2. We still would have the same final answer. So that would be it.